Hello. This is a video to make functional groups as painfully simple as possible. So right off the bat, we've got alkanes. This is basically two carbons single bonded to one another. This is often not considered a functional group by many professors and people because there's not really much going on here, but it'll help with distinguishing between the next two that I'm going to draw. So the next one is this is a line drawing up here. So if I go into the actual structure here, so this is just a carbon with two double bonds, right? So this is alkene, right? Next we have, wait for it, you never figure this out, three bond. It's a triple bond. This is a carbon with a triple bond. That is an alkyne. And just do a alphabetical order. So A, E, Y. Just add another bond as you go. Next we'll go into the alcohol, which is another very simple but very, very common group you'll see a lot. So alcohol, essentially, in essence, you'll just see a lot as an OH, right? I'll draw it here, so the line drawing. You'll see it's an OH. There's obviously this carbon here. So alcohols, basically it's just as OH. So if I were to spell it out, alcohol, you have this OH, so OH and OH, I hope that sticks. After alcohols, we can go into, I think, carboxylic acids, because carboxylic acids are also very, very common when you're learning about amino acids and protein structure. And you'll also learn more about different charges, things called Zwitter ions, so that'll be fun. So carboxylic acids, very, very, very commonly, you'll see them abbreviated as just COOH. But structurally, what they look like, if you want to think about it, is you have a carbonyl, which is a C double bonded to an oxygen, and then this is bound to a alcohol group, right? And this is one thing my professors never told me, which always made it confusing initially. Just because you see an OH doesn't mean, oh, that's an alcohol. You cannot do that. If you see it next to a double bond or something else, like some other element, you have to think very carefully about what it is, right? Because if it has other distinguishing features, such as this carbonyl, you must, that takes precedence over everything else. So this is not a carbonyl. This is not an oxygen. That is a carboxylic acid because of the carbonyl with the alcohol, okay? So this is a carboxylic acid. Okay? We talk about carboxylic acids, it's only appropriate we talk about amides and amines. Okay, so amide linkages is something you'll hear a lot about when you go into protein structure. So amides essentially have some group. So this is this would be a carbon or a hydrogen. This is bound to this carbonyl again, which is then bound to this nitrogen here. Okay, so this is a amide. Okay. So amide sounds very similar to amine, and they're different mainly because they don't have amines do not have a carbonyl, right? So if it doesn't have carbonyl, what's it look like? Pretty much the exact same thing except no carbonyl, right? I hope that's simple. And remember, star means it could be either a carbon or a hydrogen, right? So it pretty much just looks like that. Right. The only difference between amine and amide is that amide has a carbonyl. That's C double bonded to an O. Okay? I hope that is keeping this as simple as possible. Okay? Next up we have ketones and aldehydes. So ketones, essentially, you can just think of kind of being nestled between two R groups, in essence. I'm just going to draw as two carbons because I think star might get confusing here because technically you have a simple, I'll just go into it. So essentially you have this C double bonded to an O, and we'll start two carbons next to it. Okay, that's your ketone. Okay, simple enough. Aldehyde, we'll just draw as such. So again, this could be whatever you want. And then this is again bound to that carbonyl. But that just looks the exact same, right? It's same as ketone. Yeah, except aldehyde must have this hydrogen here. Absolutely must have this hydrogen. Okay, that is the difference. Wait, remember it's aldehyde. Just kind of imagine you breathe heavy. That huh sound you make, aldehyde. That's the hydrogen here. That's what differentiates ketones and aldehydes. Okay. And please note again with like the ketones here, is that this doesn't necessarily have to be like a carbon, like that could, in essence, be hydrogen. Just I'm writing it as such because if one's a carbon, if you make, because like that's the same rule here. Like if you make this that, it you would just confuse with aldehyde, right? So I just wrote with the carbon. Okay, it'll make your life easier when you're first learning about it, but then you'll learn about like some like various exceptions and things. Afterwards we have esters and ethers. Okay, so with esters, the thing that people get confused is just the name ester and ether. They sound very like similar. So, with the ester like linkage, essentially you can just think of like there being some group here. It's like obviously this is a carbon or hydrogen. This thing is bound to a carbonyl, and then this is then bound to a oxygen, and then like a carbon, obviously. So this is an ester, right? And a way you'll see like this abbreviated sometimes is like this, RCOOR. That's like you're like, R is like you're like you know, like what it could be, like that, hydrogen or carbon. But then conversely, ether is a lot more like simple. So it's just like a carbon with an O and then, whoops, and then another carbon. So that's an ether, right? So like you'll see structure, like if I make this like another color, right? Like this part and this part, they look similar, except what's different? This part, right? Yeah, ester has this carbonyl, whereas the ether does not. So again, same pattern. There's a lot of them are very similar structurally, except carbonyl can change what it's called. Next up, these are like the major ones. I can go like some of the other ones. Like I list like alkyl halide. Let's say alkyl halide. So alkyl halide essentially is like you have this some sort of like carbon thing which is attached to this group called X usually. So that's any type of like halide or like so is halogen based, right? So that could be things like fluoride, chloride, bromide, iodine, etc. So that's alkyl halide. Another thing I guess you can see is like a nitrile. Nitrile is like a C triple bonded to this nitrogen. Nitrogens are really interesting because they can do like wacky things. You see like amines and amides and nitrile. So this is a nitrile. Thiol. So thiol, OL is like sounds similar to alcohol, and that's because it is, right? Thiols essentially look the exact same as alcohol, except it's a sulfur instead of a oxygen. It's just a thiol. Aside from this, after this, you're kind of just like really picking at your, you're kind of like grasping at straws, trying to find other things. You have things called imines. So we have the nitrile. Imines are like a carbon double bonded to a nitrogen that has like these two like links out here. It's called imines. You'll learn a lot more about these when you're starting. I think like usually halfway through Argo. This is also called a Schiff base. But I'm just gonna draw a line here because these are very very like. This is when you get like a bit more into like once you get past like the initial part of organic chem and you learn these other groups. That's when you learn some of these other groups like imine, thiol, nitrite, alkyl halide. You got acid chloride. So acid chloride is like structurally kind of similar to a alkyl halide, just that it's got a carbonyl in it, right? So if I draw like a star here, that's carbonyl, and then to like a chloride, right? So this is an acid chloride. Acid chloride. You have things like phenols. But phenol is like, it's like you basically have a phenyl ring and you throw on an oxygen onto it, right? That's pretty much it. But I don't know if I would even consider that a functional group. But hopefully this was a very, very simple rendition of all the functional groups. Everything above this line are like the more common ones. Everything below this line you'll get more into when you get like a few weeks into organic chemistry and you start learning mechanisms. But yeah, hopefully this was made simple. If you have questions or comments, please say so. Please visit your professors and TAs. I promise you they're bored in office hours. They're always willing to help.